Geotrig, lesson 22. We're going to talk about absolute values first. What is an absolute value definition? What's the definition of absolute value? Okay, let's skip the absolute value definition for now. What's the absolute value of 5? 5. So we know how to use it. Possibly.
It's the distance away from 0 on a number.
It is the distance from 0. It is the distance from 0 on a number line, because distance, guys, is never negative. If I ask you, how far do you live from school, you may say something like 5 miles. But if you're at home and I ask you how far away is school, it's still 5 miles. It doesn't matter which way you're coming from or going to, it's still 5 miles. It's 5 miles there, it's 5 miles back. If I put a negative in front of a distance, that's just signifying what?
0.
No, if I say negative 5 feet, a direction. So we would have a direction associated with our movement or our distance. So we're going to talk about the distance from 0. I see that I do have a problem with the second group there. For some reason I have negative 3 equals with an absolute value on the whole thing, when it should be absolute value of negative 3, which will be 3. And the absolute value of 0 is 0. The distance from 0 to 0 is 0. Not that big of a deal, right? But now we're going to start moving into solving absolute value equations, which means I need to find the numbers that make the equation true. Here's the thing. Absolute value of some number is equal to 5. What's the answer? 5. Sure. X equals 5. Or, yes, negative 5. Or should I say, X equals negative 5. Interesting. So, because the absolute value of 5 is, absolute value of negative 5 is 5. They both work. Notice I checked them as well. But the next one starts to get even trickier, because it's the absolute value of x plus 2 is equal to an 8. So what is an x value that makes that true? 6. Okay, I can agree. 6, because 6 plus 2 is 8, and absolute value of 8 is 2, or its absolute value of 8 is 8. Is there another one? It's negative 10. So it's or x equals negative 10. But how do you know this? It's because the absolute value that you need to take can be equal to 8, because the absolute value of 8 is 8, or that absolute value can be equal to, or the thing that you're taking the absolute value of can be negative 8, because when you take the absolute value of negative 8, you get an 8. So there's a rule associated with these guys. Now I'm going to write this rule down. I hope you guys will as well. That says that if I take the absolute value of x minus a, really can be absolute value of anything, okay? Whatever's inside. And we say that is equal to c. So the absolute value of something is equal to c. I don't like absolute values, so I get rid of them. And I get rid of them by switching them to x minus a is equal to c, or x minus a is equal to negative c. You guys should have done this back possibly even into algebra 1. So you can basically say, I can get half of the problem right by taking whatever is inside the absolute value symbol and dropping the absolute value signs and set an equal and solve. Because that's what I'm doing here. I drop the absolute values. Or I drop the absolute values and set it equal to the opposite. Because as soon as I take the absolute value of C, I'll get C. If I take the absolute value of negative C, I will also get C. So whatever that is. Okay? Any questions to that? That's your rule. Drop the absolute value signs, solve. Drop the absolute value signs and set equal to the opposite. So to move along a little bit further, kick it up another notch, now we're going to get rid of the idea of equations and talk about inequalities. Remember, inequalities are not equals. They may be equal to, but you'll have that greater than or equal to, less than or equal to, or just a greater than or just a less than symbol. Okay? Now, the way we will handle these is that you still have to isolate the absolute value. So it has to say absolute value is greater than or absolute value is less than something. And it doesn't matter, guys, if I'm using the symbol of less than or equal to, they'll behave the same way. Just like greater than or equal to and greater than will handle the same exact way as well. Just like when there's an equal sign, there are two cases. There's also two cases here. So, if you look here, I should add 2, so the absolute value of x is less than 4. Someone give me an answer. When is the absolute value of some number less than 4? Give me an answer. 3. Absolute value of 3 is? 3 is 3 less than 4. Yeah, any others? 2. Any others? 1. Negative what? Negative 3. Negative 5? Let's test it. Absolute value of negative 5 is? 5. 5 is not less than 4. Okay, so now I'm here at negative 3 to positive 3. But can't that be 3.5? Can I be 3.99? Can I be 3.999999? Yes. So it's not just from negative 3 to 3, it's from negative 4 to 4, but does it include the ends? No. So let's think of it the other way. Let's go to graphing this first. We would have a point at negative 4. We would have a point at 4, right? What kind of dots do you think these would be if they're not included? They're both open dots. And all of the values that are true are where? In the middle. Now, one way we could test this would be checking 0. Does 0 work? Absolute value of 0, is that less than 4? Yes. So we would shade in the middle. So on these problems, guys, we're either going to shade in the middle or we're going to shade on the outsides. And it all depends on what inequality symbol is being used. So this one's going to be the opposite. It's going to be outward. In or out. Okay. Now, this is my answer. But wait a minute. Last time we had an equation, we only had 2 solutions. How many solutions are in this thing? An infinite many. As soon as you find a decimal answer in there, I'll find another one. Someone else will find another one after that, right? So we're not talking about a single solutions. We're talking about a range. And therefore, we will have to continue to state these using inequalities, which in set notation would have inequalities in it, yes. Or we could use interval notation if you want it. So our answers, if I was using my inequalities, would have to say something like negative 4 is less than x, which is less than 4. I just solved it. I stated the answer and I have a graph. But that's just taking the absolute value of a number being less than something. If you take a look over at the next problem. It's the absolute value of an x minus 5 is greater than or equal to 2. Right? So that means this thing itself, the number, when I take the absolute value, is bigger than 2 or equal to. So if I made a number line real quick, what's a number that will work? 7? 7, if I put 7 in, it'd be 7 minus 5, which is 2. Absolute value of 2 is, and is 2 greater than or equal to 2? Yes, that would actually have to be a closed dot. It's included in there. That's good, it works. What's another number that works? 8. Does 8 work? 8 minus 5? Absolute value of 3? Bigger than or equal to 2? Yeah, that works. Okay, good, good. Oh, anything greater than 7. You guys agree with this? So as long as it's 7 or above, can it be something less than 7? Can it be 6? Can I be 6? Why not? 6 minus 5 is 1. Isn't 1, absolute value of 1, bigger than or equal to 2? No. So 6 does not work. Guys, this would be not a way to do this. I'm just doing this so we can start to formulate where our numbers will be. 6 doesn't work. 5? No. 4?
No.
3?
Yeah.
Ooh. I'm hearing yes. And I'm hearing no. So we're going to mark this as a working point. But what's 3 minus 5? It's negative 2. Absolute value of negative 2. Is that greater than or equal to 2?
Yeah.
It does work. Ooh. Will 2 work? Oh. So wait a minute. Anything smaller than 3 will work.
Well, that's weird.
How the heck? So an absolute value all of a sudden now goes outward? Jumps over the middle numbers?
Yeah.
So it's x is less than or equal to 3?
No.
And
Oh, yeah.
x is greater than 7?
I think.
Or? So we would say that x is less than 3, or x is greater than, or equal to, 7? Would that be the answer to that in inequalities? But how the heck do you get that? Can anybody formulate a rule for each one of these? What if I said this? Oh, sorry. I'll change that one. Let's do the other. Keep them in order. Less than C, or less than or equal to C. It doesn't matter. Here's a really cool rule. If you see this, okay, where you have some kind of absolute value being less than C, or a number, here's a cool thing. Just like before, I'm going to drop the absolute values. Look above. Our question was, when does the absolute value of x be less than 4? Half of the answer is right here. X is less than 4. Isn't that the same thing we did here? Just take the absolute value signs away. And then it says, but it's greater than the opposite of 4. Ooh, so then it's just the opposite of C. These things, guys, are called compound inequalities. Compound inequalities. We have one like the first type here that we just solved for. These are ands. They go towards each other. It's this and that. Because it has to be both bigger than 4 and less than 4. Or bigger than negative 4 and less than 4, right? It's and, both. This one is an or because it can be x is less than or equal to 3, or x is greater than or equal to 7. It's here or there. Maybe we're going to an amusement park and there's a certain ride that says you need to be at least 5 feet tall or 16 years old to ride. If you're only a 4 foot tall but you're 17 years old, can you ride it?
Wait,
Yes, it's an or.
Oh, it was an or, right?
You met one of the requirements, you're good to go. What if it said you had to be 5 feet tall and, or bigger, and you had to be 16 years old?
So if you were 5,
So
6, and you were 12 years old,
you cannot ride. Okay?
You have to be both.
So you'd have to meet both requirements. That's an and, right? So let's take a look at the other situation. And the other situation, I am still going to say absolute value of x minus a, but what happens if it's greater than c? Seems like the same thing happens. I can get half my problem just by removing the absolute values. Or x minus a is less than negative c. I take the opposite, set it equal to the opposite. Remember last time we said it was equal to the opposite of c? But here's the thing, when working with inequalities, when you kind of multiply things by -1, what happens to the inequality sign? It needs to flip or switch, right? So that's why when you get to here, that it's x minus a is less than negative c. Okay, so using that information, I would like you to solve this inequality of the absolute value of 2x minus 1 is less than 4. I'll give you guys a couple seconds to do this. What's my first step, guys? Get rid of the absolute values. So it should look like what?
2x minus 1 is less than 4.
2x minus 1 is less than 4. And then I'm gonna move this. I don't know why I put it over there, but okay. Is this an or an and? Oh, maybe. Oh, wait.
Oh, I forgot about that.
This is an and one.
Yep.
Now here's a cool thing. It should be less than 4, but then you also can say it's greater than
Negative 4.
-4. But watch this.
But you gotta break it into and.
What if I did this? Instead of using or, I said and 2x minus 1, and use the same logic as before, flip the sign and
Greater
greater than
than.
-4. But doesn't the second half here saying that this group is bigger than -4? Isn't that this half over here? But it's less than 4, which is the right side of it.
So it's both.
So you can use either option.
Oh.
I just think it's cleaner to write it as one compound inequality versus two separate. Okay? So your choice. You could, because that's using the second method here keeps in tradition or keeps with the flow of the or and the and. The only thing you'd have to worry about is that word in between. Is this an or statement or an and statement? And you'll know as soon as you graph it, ands go towards each other, ors go away. So now we just need to solve for x. The rule is what you do to the middle, you do to the outsides. So I got to get x by itself in the middle. What's the first thing to get rid of? Add 1. Add 1. Add 1. -4 plus 1? -3 is less than 2x is less than 5. Divide everything by 2 and 2. -3 halves is less than x, which is less than 5 halves. On a number line, this is -3 halves. Open or closed?
Open.
They're both open. And where do I shade? It's in the middle, but say I did not know this. Isn't 0 in the middle? Does 0 make this thing true? Is 0 bigger than -1.5, but less than 2.5?
Yes.
Yes. Trade. Boom. Done. Okay. Homework for lesson 22 is page 163. This is day 1, 4, 6, 9, 13, and 28. Have a great day.
Every